Let us try to understand further about this binomial probability distribution by looking at the example here. From past experience, a manager of an upscale shoe store knows that 85% of her customers will use a credit card when making purchases. Suppose 3 customers are in line to make a purchase. The first question, does this example satisfy the condition of a Bernoulli process? This example satisfies the condition of a Bernoulli process because a customer either use a credit card with the probability of 85% or not use a credit card. So if the probability of use a credit card is 85%, the second outcome is not use a credit card would be 1 minus p equals to 1 minus should be this should be 100% minus 85% equals to 15%. So here this experiment has 2 outcomes: using a credit card with a probability of 85% or not using a credit card with the probability of 15%. Moreover, given a large number of customers, these probabilities of success and failure do not change from customer to customer. Now the second task, to construct a probability tree. We can use probability tree whenever an experiment can be broken down into stages. Here we can view the probability of the use of credit cards by each customer as a stage or as a trial. And we assume here that each stage is independent. Let us denote S as the outcome that a customer uses a credit card. So PS equals to 85%. And F, customer do not use credit card. So PF is equal to 15%. So to construct this probability tree, so let's start with an unlabeled node on the left corner for customer 1. We have customer 1 have the probability to use credit card and not use credit card. Then construct a branch that originate from customer 1, which denote conditional probabilities of customer 2 using credit card or not use credit card. This is for customer 2. Remember that each stage is a trial, which we assume is independent. So this is a conditional probability for customer 2, condition to what customer 1 use. But the probability of customer 2 here is independent. So the probability that customer 2 uses or not use credit card is independent to whether or not customer 1 use a credit card. Thus, the conditional probability is the same as the unconditional probability. This will stay the same. Probability 85%, 15%, 15%, 85%. I should write here also 15%, 85%. The third stage represents the probability of the use of credit card for customer 3. We have customer 3 the same as F, S, F, S, F, and S, F. Here, The condition also holds the same. Probability of using credit card 85% and you not use credit card is 15%. So it will always be the same. So this is a conditional probability for customer 3, and the conditional probability is independent, so it's an unconditional probability regardless of what customer 2 uses. Now we have completed the probability 3. Remember, when we learn about probability 3, the next column here, this column, will result a joint probability. We will have the event well where the probability of customer 1 and customer 2 and customer 3. The first result is S, S, S. So we can say that all the 3 customer uses credit card. 2 out of 3 use credit card, and so on. Now we have 8 joint probability event, and each probability, each event is obtained by using the multiplication rule for independent event. So we can say that to get the probability of 3 customer using credit card, all using credit card, is 85% times 85% times 85%. 85, 85 times 85. The second one, 2 out of 3, 85, 85 times 15. And so on, you do the same for the rest. I have used Excel to calculate for each of 8 joint probability event, and this is the result. And to make sure that your calculation is correct, this 8 probability event should all sum up to 1 or 100%. Now that we have constructed the probability tree and find the joint probability event, our next task is to derive the binomial probability distribution. We can combine events with the same number of success using the additional rule. We use the additional rule for mutually exclusive events. For instance, in order to find the probability that one customer uses a credit card, we add the probability that corresponds to the outcome. So for one customer that use a credit card, we have this event, 1, this, and this. So probability that x equal to 1 is 1.91% plus 1.91% plus 1.91%, because there are 3 events, which is equal to 5.73%. Px equal to 2 is the one that has 2 success events. You have this, this, and this. So 10.84 times 3, because you have 10.84% plus 10.84% plus 10.84% equals to 32.52%. And all 3 use credit card. You only have this event, 61.41%. And none uses credit card is just equal to this event, 0.34%. Let's make your probability distribution more neat You make it into a table like this. So you have the probability for none customer uses credit card and only one customer uses credit card. The probability is 0.0573. Two customer 0.3252, and three customer is just 0.6141. Here I calculate still in percentage, and in this table I convert it into decimals.